recording. Okay, we're recording now. And we're going to do lesson 2 in this booklet. Everybody got the booklet? If anybody can't find theirs, I do have some extra ones, I think. You can't find yours? You know you have it, right? You were here for lesson 3. Let's see if I can find it. Let me see if I can find you next one. There you go. There you go. Okay, everybody else found theirs? Everybody else got yours? Okay. Dude, you got yours? That book. Find that book. Come on. Stay focused, man. All right, here we go. Right now, we have found probability using the formula. Okay, we've written this formula down like 3 or 4 times, so hopefully this is now common knowledge. Probability of an event equals, I'll just stick to desired over possible. Another way to think about probability is in terms of odds against an event occurring, or odds in favor. That's an F. Let me rewrite that. That's ugly. Odds in favor of an event occurring. And we're Canadians. We put a U in the word favor. Odds is a ratio that compares the number of possible successful outcomes to the number of possible unsuccessful outcomes. See the difference between probability and odds? Probability is always successful out of total, desired over possible. Odds is success to not success, yes to no, desired to not desired. So I'm going to actually write that as a little formula. Odds in favor of an event are, and I'm going to have to write this kind of small because they don't give me a very big box. Number, here I could just, of course I can make it bigger though, can't I? Ah, too big. Number, that's the word number. Number of ways event can occur divided by number of ways event cannot occur. So there is our new formula. Can over can't. Success over fail. And I actually hate the fact that the curriculum lets me write that as a fraction, because this isn't the way I think about fractions. I'll explain more what I mean in a minute. Now, that's the odds in favor of an event. The odds against an event is just to flip this over. So it's number of ways event cannot occur on top divided by number of ways event can occur on the bottom. Notice that they're just flipped over from one another. There's a big fancy word for that that begins with the letter R. They're reciprocals of each other. Very good. So, I'll give you a sec. I know that's a lot of words to jot down for one little formula. Now, I got to take you back to grade 7 in the Wayback Machine. I wish I had a harp. I could make that harp sound. And now we're back in grade 7. And in grade 7, when they were reminding you how fractions worked back in elementary, right? You first saw fractions, I would think, in elementary school. All right, you don't have to write this down. Just think this for me. And again, I have some guys kind of tuned out. Stay with me here. This is kind of complicated, even though it's only elementary and grade 7. You got to think about this. When you were talking about, say, black to white, you probably went, oh, black to white, 1 to 4, right? Well, wait a minute, no, that would be black to total pieces. Black to white would be like this. But if I asked you what fraction does that picture represent, would anybody here go, oh yeah, it's that fraction? In fact, most of you, if you were playing teacher, would probably take out your red pen and go, no, no, no. Oops, that's not a red pen, is it? You'd probably take out your red pen and go, if the kid wrote 1/3 like that, you'd go, no, sorry, kid, that's supposed to be 1/4. But you know what? Under the right circumstance, you could say that that's true. If the person writing it down meant not 1/3, because this isn't 1/3. If what they meant was this, they just wrote it in ratio form. In other words, ratios can be part to part, or they can be or they can be part to whole. Almost nobody would have a problem with that. If I said, hey, what's the ratio of black to white? 1 to 3. But if I said, what's the ratio of black to pieces? Oh, 1 to 4. But you can actually write that as this. This one can be written like that, and this one can be written like this. And they're both correct if you're thinking about them as ratios, not fractions. So context matters. Right? Do you know what I mean by context matters? I think we had this conversation not too long ago, right? How are you thinking about that sentence? What picture is in your head right now? Are you picturing me looking out my window, holding my binoculars and spotting my neighbor's dog? Or are you picturing me looking out the window and there goes the neighbor's dog and he's got my binoculars in his mouth running around? I saw my neighbor's dog with my binoculars. Does my neighbor's dog have the binoculars? Or did I use my binoculars to see the dog? I guess I need context to know, don't I? The words here alone don't tell the whole story. I need to understand the situation. And that's actually true here too. Okay, so when we are going to talk about odds, I like ratios the best. I wish I lived in a world where anytime it's probability, we just do fractions, and anytime it's odds, we just do ratios. But apparently, we have to get along with other people in other parts of the world or something. And in other places and in other cultures and in other situations, some people don't like to use this ever. They always write everything as number / number. Sometimes they even write it like this, 1/ something like that, like they're typing or something. And what do they mean by that? Do they mean 1/3, part to whole? Or do they mean 1 versus 3, part to part? Do they mean 1/3 things, or do they mean 1 of this thing and 3 of that thing? It depends on context. So, with that rather confusing issue sorted, let's get back to maybe making that a little smaller. What's the probability of rolling a 2? Okay, well, we've done lots of that, no problem. 1 out of 6, or 1 to 6, right? Desired, possible. If it's a probability, that's the number it has to be. But if I ask you what's the odds in favor of rolling a 2, not the probability, the odds, I write it as 1 to 5. And again, my hand almost is resisting writing it this way because I hate looking at it this way. But it's not wrong to write it like that. But I have to understand that that's not really a fraction anymore. It's a ratio. It's 1 to 5, not 1 out of 5. And I even say 1 to 5. I don't say 1 out of 5. Just like if I had that sentence, I saw my neighbor's dog while I was using my binoculars, or I saw my neighbor's dog by using my binoculars, well, there's no doubt now. Now I'm not imagining the dog running around with my binoculars. I'm using the binoculars to see the dog, and that's perfectly understood when you hear that sentence. No more vagueness, no more ambiguity. So when I say 1 out of 5, I clearly don't mean that this answer is this. Okay? So, what are the odds against rolling a 2? How many things aren't 2 when you roll a die? Or again, you can write it down as 5 to 1. And again, that's not 5 onths. That's not 5 over 1. Right? You have been trained over the last 5 years of math education to go, oh, I wouldn't write it like that. I just write 5. In this case, you couldn't do that because this isn't really a fraction. It's a ratio. And it's not a part-to-whole ratio. It's a part-to-part ratio. All right. We've already done these. This will go fast. Tree diagrams. What is a tree diagram? I guess we never wrote down what it is. It is a type of, I guess you could even say it's a type of graph that displays all possible outcomes of an event. And each branch represents a different outcome. Okay, so we've done some tree diagrams. Let's do one together here. I usually write them from top down. Let's write one sideways. It doesn't matter. Trees can grow sideways in mathematics. A coin is tossed 3 times. We've kind of done this one already, so let's make it look a little different this time. First toss can be head or tail. After the first toss, you can get head, tail, head, tail. After the third toss, you all right? There. Sideways tree diagram. Doesn't matter which way you draw them. Some people like them this way. I kind of like top down. It's all good to me. So, what are my possible outcomes here? Let's list them. Basically, follow every branch, and it tells you the outcome. So let's follow this branch here. Starting with the first toss, you get heads. Then the second toss, you get heads. Then the third toss, you get heads. So one of the outcomes is heads, heads, heads. Oh, but that took away the pen mark, dude. Rats. And then the next outcome will be, let's follow the branch again. Heads, heads, tails. So my next one's going to be heads, heads, tails. Do you see how I'm counting on the tree diagram? What's the third branch I could get? Heads. Oh, hang on, I'm going the wrong way. Oops. Heads, tails, heads would be the next branch. Heads, tails, heads. What's the next branch going to be? Let's try it again. Heads, tails. I haven't gone that way yet. Tails. Head. Oops. Ah! Heads, tails, tails. There, that took care of all 4 branches that originated from my original heads toss from the first coin toss. Then there's 4 branches that originate from there. Do I have to highlight them? Can you see them? Tails, heads, heads. Tails, heads, tails. Tails, tails, heads. And lastly, tails, tails, tails. 8 possible outcomes. So determine the probability that all 3 tosses landed heads. That is 1 out of 8. So as a probability, desired over possible. But what is that in odds? 1 to 7. Odds in favor. 1 way of what I want, 7 ways that I don't want. Determine the odds against all 3 tosses landing heads. 7 to 1. Okay. All right, let's do the same thing for a die. A 6-sided die is rolled. What is the probability of rolling a number less than 3? Okay, so what are the numbers less than 3? Well, 1 and 2 are less than 3. So that would be 2 out of 6 is the probability that I roll a number less than 3. Again, if I leave an answer like that, though, I'm going to lose half a mark. What can I do with the fraction 2 out of 6? And if you need your calculator to help you simplify fractions, by all means use it. Type this in, hit your fraction button, and boom, it should simplify it down to 1 out of 3. One of the good things about this course is if those junior high skills of working with fractions were never quite mastered for you, we'll let your calculator do the thinking for you on that. We want you to understand the probability, not we don't care if your mechanics on fractions is a little weak. Maybe later in your life you'll pick up your fraction skills. You never know. Many times when I was having parent-teacher interviews with junior high parents, I had a parent would actually tell me, would actually admit and confide in me that, you know, I never really got math when I was in school, but now that I'm helping my kid with their homework, and you know, I'm a grown-up now, and my brain's a little better functioning, I really get this now. And my kid thinks I'm a wizard, that I mastered math, but no, it just makes sense now, and it didn't when I was younger. And I said, well, it's like, yeah, you're going through puberty, your brain wasn't finished yet. So you know what? Math isn't your strong point in school. That can change. You will be an adult. You'll be smarter someday. All right. What are the odds of rolling a number less than 3? So again, what's the odds? I don't like writing odds as a fraction, so I like going ratio. What is the number of things less than 3? 2. What's not success? Rolling a 1 or a 2 is a success. Rolling a 3, a 4, a 5, or a 6 is a fail. 2 to 4. I'd lose half a mark if I left it 2 to 4. How come? Because ratios simplify the same way fractions do. Why is 2 out of 6 equal to 1 out of 3? Because you can divide the top and the bottom numbers by 2. What can I divide both of these numbers by? Also 2. That makes a good trivia question. In what type of math does this equal that? When I say that that's the probability and that's the odds. In this case, they're the same. The probability of rolling a number less than 3 on a die is 1 out of 3. The odds is 1 to 2. And again, listen to my words. Out of 2. 1 out of 3. 1, 2, 2. There we go. Context matters. The dog has my binoculars. The odds against rolling a number less than 3. Well, again, 4 things are not less than 3. 2 things are less than 3. And again, that simplifies to 2 to 1. The odds against me are 2 to 1. Given that the odds in favor of an event occurring is 5 to 2, determine the probability of the event. Ooh, we got a nice little formula here. So the odds in favor goes on top, and on the bottom, odds in favor plus odds against. So the probability of the event happening is 5 over 5 plus 2. So the answer is 5/7. All right, you don't have that, at least not yet. You will. I will put together a little handout of that. But for right now, the actual assignment I want you to work on is, first of all, we're going to get some practice with tree diagrams. So I think the first part of the assignment I got is tree diagrams. Here, can you see that? So in your booklet, we're going to skip assignment 5. You're going to do assignment 4, but you're not going to do it all. Number 5 takes forever, and our experiment kind of dealt with the stuff just like number 5. So we're just going to do 1 to 4 in assignment 4. And then in assignment 6, I don't like question 4, so we're going to do 1 to 3 and 5 to 8. So that's the homework. I guess I can stop my little video lesson. That's it for the video. That's it for the lesson.